So our final topic for today, in preparation for tomorrow when we do practice problems on factoring and distributing, is how to solve quadratic equations using factoring as a strategy. So generally the steps are you first factor, and then once you have factored form as you have here, you can assume that if two things multiply to be 0, either the first thing, a plus b, or the second thing, c plus d, had to be 0 and solve the equations algebraically. So our first step is factor, and our second is to set each piece equal to 0. So if I factor this first equation, I've got x and x, and I need to think through what multiplies to be a negative 54 and what adds to be a negative 3. So if the two numbers add to be negative 3, that means the difference between them can't be a very large number. So thinking through our factor pairs of 54, I know that 9 times 6 is 54, and 9 and 6 are also 3 apart. So I'm going to say it's x minus 9 and x plus 6. That would give me the negative 9x, and the positive 6x, that would give me my negative 3x that I need. So this is factored form, and we're done with step 1. Step 2 is to set each equation equal to 0. So what that entails is to say if the two parts multiply to be 0, either x minus 9 was 0, or x plus 6 was a 0. And then from here we do quick algebraic solving. So if x was a positive 9, or if x was a negative 6, you would get a 0 as an output. And you can take these numbers and plug them in either to factored form or into the original equation. If you plug either of those in as x, when you do x squared minus 3 times x minus 54, both will yield 0. Okay. This next one that we've got here is really similar. We just have to first get everything on one side before we can start. So let's first rearrange everything where everything's on one side. So we'll have 6x squared minus 7x minus 3 equals 0. Now thinking back to our factoring flowchart, my first question is there a greatest common factor? And in this case, a 6, a 7, and a 3, there's not. Kind of going down our flowchart, I'm just going to erase this so I can kind of highlight my path. So going down my flowchart, I would say no. How many terms? I'm at 3. And then if I look through here, it's not looking like that pattern of a perfect square trinomial, so I'd say no. The coefficient of the first term is not a 1, so that means we're going to be doing our guess and check. Okay. So guess and check says that it could either be a 6x and a 1x, or it might be a 2x and a 3x. That gives me the 6x squared. And then the only thing I need to think through is a 3 is a 1 and a 3, right? That's the factor pair that must give me a 3. And so I have to think through, using my pair, I can either take one of the numbers and multiply it by 6 and combine it with the other number, or I can take my two numbers and one gets multiplied by 2 and one gets multiplied by 3. And then they have to combine to create that negative 7x. So let's think through. I could do a 6. If I did 6, it wouldn't make sense to do 6 times 3. That would be too big. I could do 6 times 1, which is 6. And a 6 and a 3, that can't really get me a 7 by adding or subtracting. So that means I have to do a 2 and a 3. I'm going to start this way, and I can also flip-flop which one gets times 2 and times 3. So a 2 times 1, that would be 2. 3 times 3 is 9. A 9 and a 2 could give me a 7 if I did 9 minus 2 equals 7. And let's say I want it to be a negative 7, so I want the 9 to become negative. So I'm going to do a negative 3 and a positive 1, because then you'll have the negative 9. Notice that's coming here from the negative 3 times the 3x, and the 2x times 1 is going to be a 2x, and a negative 9x plus a positive 2x will give me that negative 7x that I want. Oop, but we're not quite done yet. right? Some people will stop there by accident. We are asked to solve for x. So solving for x means I now have to take each of these pieces and say, okay, when would 2x minus 3 make it 0? When would 3x plus 1 make it 0? And this one, you have to do it a little bit more algebraically. The last one, you might have been able to kind of eyeball the answer. So if 2x is equal to 3, x is going to be 3 over 2. I'll just write that a little bit cleaner. 3 over 2, or x is 1.5, right? Whichever you want to write it. Subtract 1 for this one. 3x is equal to -1, so x is -1/3. Okay, so that's just the basics of solving by factoring, and you've got some practice problems in your notes packet, in your course packet. The other tidbit that is in this section for the competition math curriculum from the Art of Problem Solving book that our course packet follows is using the quadratic formula. And using the quadratic formula, it's really a last resort if you can't solve for x with any methods. It's not factorable, you get stuck. So this is the Hail Mary option for say. So what this is using your general formula of ax squared plus bx plus c equals 0. Remember, a, b, and c are your coefficients. You're going to use those numbers and plug them into this formula. And x is equal to all of that. Notice because of the plus or minus, that's how we can get two solutions. Quadratics always have up to two solutions. So from here, what I want you to do is using your formula and using this equation, I want you to set up the problem and plug it into the quadratic formula. Unpause it when you're ready to double check your work. Okay, there is the worked out answer. Make sure you're careful with your signs, right? Double check if you missed a positive or a negative sign throughout your work, if your work isn't matching my numbers. One thing I want to point out is that over here, this work here is simplifying square roots or simplifying radicals. It's something we're actually going to cover later this week. So if you haven't seen this before, it's okay to have stopped over here at that answer if you had never seen square root simplifying. If you have seen square root simplifying, you would want to break it down into the square root of 4 and the square root of 11, as the square root of 4 simplifies to a 2. And then notice I highlighted the 4, 2, and 4 yellow because they're all divisible by 2, so you can actually divide all the numbers by 2. Notice instead of having nothing, right, it's like having a 1 in front of the square root of 11. So that's how you get to your final simplified answer. But like I said, if you've never seen square root simplifying before, I would stop at where I boxed it with a highlighter. Okay. And then if you're curious about how to prove the quadratic formula, I'm not going to go through it in this video, but I will tell you that if you're curious and you've seen these ideas before and you want to explore more, I would look it up online. I'm sure there's lots of YouTube videos and resources. The proof does involve completing the square. So if you haven't heard of that idea, it will be a new idea that it introduces in the proof. I'm just cutting this in the video and not going over it just because I want to make sure the videos aren't too cumbersome for you guys working on it at home. So with all this e-learning, I'm just trying to cut out things that aren't as essential so that you guys aren't overwhelmed with tasks that need to be done. Okay, like I said, if you're curious, go ahead and look it up. There's lots of videos online. And that is it for today. I'll see you guys later.